In this video we're going to prove the diagonals of parallelogram bisect each other. So we're going to begin in the algebra and graphics view, the algebra view, and we're going to be creating a parallelogram. So let's begin. So I'm going to start with a line. Definition of a parallelogram says that the opposite sides of a quadrilateral are parallel. So let's create a parallelogram with that definition. And now I'm going to put a line through these two sides, and then make another parallel line. Intersect, and then use my polygon tool in the counterclockwise direction, and always check my work by using the angle tool. For every parallelogram, opposite angles are congruent, so this is true. So let me change my color, and I guess I'll go with this color today, and I'm going to remove my lines. And what I'm going to be doing is I'm not going to show my object, but I'll go back and create these guys. Oh my goodness. Alright, so let's do that here. So I'm going to go to my geometry view, and I'll bring back in these segments without having a label on them. And so what we're going to be proving in this proof is that the diagonals bisect each other. So let's create the diagonals, and let's intersect them. And so what we're proving is the distance. Well, we need a label on this. Let's just put a label on this. Show label. So we're going to be proving the distance from A to E is congruent to the distance from E to D, and these two distances are congruent. So let's start by saying what we're doing here. We're doing that. We're proving that the diagonals of a parallelogram bisect each other. So let's do that. And so I'm going to use a two-column proof. And every proof, I always write the left-hand side is going to be my statements, and the right-hand side are going to be my reasons. And the first line of every proof is what's given. And I'm going to actually remove these strokes because this is what we're proving, but we don't have that shown in there yet, so I want to remove those strokes and go back to my geometry view. And so we're going to be given that we're given parallelogram ABDC. Now next line is going to be, as all parallelogram proofs are, definition of parallelogram. The opposite sides are parallel, but I'm only going to do two sides today, and those two, oh actually I'm going to do all sides. Sorry about that. Opposite sides are parallel. So let's mark that. We know that we could show that it's true by opposite sides are parallel means the opposite slopes are congruent, and they are coming out as congruent. This is a construction, so you can move on the vertices and it'll always be true. I'm going to remove that for right now because by showing opposite sides are parallel, I'm just going to be using the parallel line, a line tool, and just show that the parallel this way by marking it. So I'm going to use my polygon tool to show you where we're going with this proof. All I need to show is that this top triangle is congruent to this bottom triangle. Let's change the colors so they contrast. Did I change the right one? No. And we'll color it this color. So we're going to be showing that oh wow, I really messed this one up. Let me try one more time. I have to make sure I hover over it and it says triangle. Try that again. That says quadrilateral, so I'll show you how to fix that when I want to go to a triangle. Let's see where it says triangle. There's two triangles. I'm going to be working on this one right here, and I change this color. I'll make it this color. There, I got it this time. So it is really fun to do this in Geogebra. It's absolutely so much fun. First off, we need to have at least one set of sides, and we're going to use the property that the opposite sides of a parallelogram are congruent. So we only need to mark these sides right here. This side is congruent to this side. That's all I need. And you're allowed to use the properties to prove this theorem, but you just can't use this to prove itself. So let's write down that AB is congruent to CD. I'm going to move some of these labels out so you can see them better. And when you do this, when you're actually showing these segments are congruent, you actually have to put this little line on top. Now we have a lot, but not everything. These, because these are parallel and this is a transversal, we can say that this is congruent to this angle. So let's mark these angles properly, which would be angle DAB. Oh, I need to have an angle mark. Angle, oops, I didn't get it right. Angle DAB is congruent to angle ADC. Takes me a little while to think it through, and those are alternate interior angles. And so let's see, there's also one more pair of alternate interior angles, and they're right here. See, these are parallel, this is a transversal, but this is a transversal. So I can say, this is so much fun, I can say the angle ABE is congruent to angle DCE by alternate interior angles. And now we have enough information to say the top triangle is congruent to the bottom triangle, but we have to get those letters right, so let's make sure we get those letters right. Triangle AEB is congruent to triangle DEC. And let's move some stuff around so they're not quite in the ray, and the reason for that is angle, side, angle. So we're going to write down angle, side, angle postulate. Next, we're almost there. It's going to be CPCTC is our last line. And I'm going to redo this. I'm going to put this up again because I didn't really get it in there. CPCTC, which is corresponding parts of congruent triangles are congruent. We can say that AE is congruent to ED or DE. Notice the first two lines are congruent to the next two lines. This is so much fun. So AE is going to be congruent to the first two letters, which are DE. And we can say that CE, which is the last two letters, is a congruent to EB. So let's write that down. Be nice if I had the text there. So we can say CE is congruent to EB. And we're going to put the little lines over the top because that's what is expected in all of these. And we are finished. So let's finish our proof with our little symbol saying that we're done. And we have finished this proof, and I hope you enjoyed watching this video. Thank you so much for watching. And it looks like my strokes, let me just fix this up a little bit before I finish this off. I'm going to remove my strokes because they're all messed up and go back to my geometry view and show what we actually did prove. Is I'll just go through this real quickly. We showed that because these two are congruent because of the property, the opposite sides are congruent. These were alternate interior angles, and this was an alternate interior angle. Therefore, the two triangles are congruent, and by corresponding parts of congruent triangles are congruent, we can say that this is equal to this, and this is equal to this. The diagonals bisect each other. Thank you so much for watching.